Hello friends, welcome back. In my previous presentation, we have seen how a balanced transportation problem can be easily solved using Excel solver. Now, let us switch our focus from the balanced transportation problem to the unbalanced transportation problem. I have an example of an unbalanced transportation problem where you have 5 supply points and 6 demand centers. The total supply available in the 5 supply point is 3068 and the total demand in all the 6 demand center is 3383. Since the total supply is not equals to the total demand, this problem comes under category of unbalanced transportation problem. Now we should also carefully observe over here the total demand is greater than the total supply, which implies the total available supply will not be able to fulfill all the demand centers. So in a way, some of the demand centers will receive lesser number of units. Now let us check how this kind of transportation problem can be formulated in the linear programming formulations. Before that, we go back to the formulations of the balanced transportation problem. This was the formulation that we had for the balanced transportation problem, with 5 supply points and 6 demand centers. We have the objective function in the form of minimization of the sum product of the unit cost and the corresponding variables, the set of the supply constraints, the set of demand constraints, the condition for the balance. All the supply and demand constraints are satisfied with equality. Now, let's come back to the unbalanced transportation formulation now. This is the formulation of unbalanced transportation problem. The same objective functions, the sum product of the unit costs of transportations and the variable, the supply constraints, the demand constraints. See, we can see over here in the demand constraints, the relations are no longer equality. It's being replaced by less than or equal to. This is because some of the demand centers will be receiving lesser number of units than it requires. So let's now come back to the example that we have. So what I'm doing over here is I'm creating the solution space to go to the solver. This space, which is this space over here, will provide the values of the distance variable x11, x12, so on, and finally x56, right? So let's create the left hand side of the supply constraints. It will be the sum of the variables in the first row. Let's apply the formula to the remaining rows. The relations as we had seen over here for the supply is equality. So the relation will be equality. Let's apply this in the remaining supply constraints, and similarly for the demand constraints, it should be the sum of the variables in the first column. Apply the formula to the remaining columns, and then the relations check the relation for the demand constraint. The relation for the demand constraint is less than equality, so I'm putting less than equality instead of equality, then apply the same to the remaining columns. So the supply and demand constraint are created. Now let's write down the formula for the objective function, which is a sum product of the variable space and the unit cost of transportation space. Done. Now let's go to solver. Let's reset everything. So this space is for the objective cell formula that you have created. The objective is minimization. This is the minimization of the variable space that you have created by changing this variable space at the constraints. First, the supply constraints. The relation for the supply constraint is equality. Then the right hand side of the supply constraints, the left hand side of the demand constraints, relation is less than equality, and the right hand side of the supply constraints. Okay. Check the non-negativity conditions, select the simplex and click OK. Solver found as solutions, all the constraints and optimality conditions are satisfied. Now let's keep the solution and come out. See, this is the final optimum solutions. You have a total of 305 unit transporting from S1 to D4, 416 from S1 to D6 and so on. And the total minimum cost of transportation is 86990. Let's find out the slack. Slack will be the right hand side minus the left hand side, right? So these are the values. So the third demand center is not getting all the units. The remaining demand centers have got all the required units. So what was the difference over here? The difference over here was, so this was the difference and this number can be seen over here. So this slack value gives the unsatisfied demand for that particular demand center. Now, this was in the case when the total supply was lesser than the total demand. So when the total demand was greater than the total supply, we have the less than equality over here. If in case the total supply is more than the total demand, the less than equality will come this side and the equality will go in these directions. And this is how we should handle an unbalanced transportation problem using MS Excel solver. Thank you. Kindly watch the video.